Hello and welcome to the last session of Bayesian learning. So in this final session of Bayesian learning, we will just have a revision of the different types of naive-Bayes classifier. We will just go through brute force Bayes algorithm and Bayes optimal classifier with a problem on it. So we have learned about naive-Bayes algorithm and problems we have done with respect to naive-Bayes algorithm. Now there are, other than that, we have other different or popular types of naive-Bayes classifiers. We have Bernoulli naive-Bayes classifier, we have a multinomial naive-Bayes classifier, and the third one is multi-class naive-Bayes classifier. Bernoulli naive-Bayes classifier, it works specifically for discrete features. Okay, and hence it is more useful to text classification where all the features are binary. That is, you will classify the feature either into two values. Let's say the words will occur or not. So you are using Bernoulli naive-Bayes classifier primarily for binary classification. If I am using this classification method for text classification, I can just finally say whether the word will occur or not, yes or no. So for binary classification, I can use Bernoulli's naive-Bayes classifier. But suppose I want to I want to do for categorical data. Right, I have categorical data in my training data set. Let's say I want to do just an example. Let's say I want to do text classification where each feature will have an integer value which will represent the frequency of occurrence of words. So I have, let's say, so many this is my text that I have in my training data set, right? So how many times for has occurred, how many times yes or occurred. So in such cases where I have to do classification for categorical data, then I go for multinomial naive-Bayes classifier. The third one is multi-class naive-Bayes classifier. So that means if I do not have just two classes, if I have more than one class, right, then I go for multi-class naive-Bayes classifier where the target feature will have multiple classes. Now there's one more algorithm that is called as brute force Bayes algorithm. Now this algorithm, the concept of this algorithm, basically it relies on concept learning where the hypothesis space H for the training data set T, here we will be computing the posterior probability for all the hypotheses. We also find out the map which we have discussed before in naive-Bayes algorithm, that is we will be computing maximum a posterior hypothesis where we find out which is the hypothesis with the maximum posterior probability. But the disadvantage of this method is the algorithm is expensive since it requires computations for all the hypotheses. For all the hypotheses I will be computing the posterior probabilities and hence it is expensive. There is one more classifier called as Bayes optimal classifier. This is also a probabilistic model, right, where we find the most probable classification for a given test data. We combine the predictions of all the posterior hypotheses and from that we choose the maximum probable hypothesis or the most probable hypothesis. Okay, so given a new instance or a test data, we will be classifying using this formula. What is the suppose I have two probabilities, right? Probability that the hypothesis belongs to class CI or probability another hypothesis, let's say it belongs to T. So which is the most probable value, which has a maximum probability, that would be chosen as my new class for as my class for the new instance. So let's see a problem to get a better idea. Suppose I have a hypothesis space with four hypotheses H1, H2, H3, H4. We have to determine if the patient is diagnosed as COVID positive or negative using the Bayes optimal classifier. So let's say from the training data set, the posterior probabilities are already given in for you. Okay, so the hypothesis given, four hypotheses we have. For all the four different hypotheses, the posterior probabilities are given. Okay, the posterior probability for, let's say, first hypothesis for the class T, that it belongs to class T, where if it is positive, right, probability that this hypothesis is positive is 0. Probability that this hypothesis is negative, that is it is COVID negative, is 1. So basically the posterior probability values are given for you in the question. Okay, now from out of this I need to find out which is having the maximum probability, right? So I will be finding HMAP, where we choose which hypothesis has the maximum probability. So looking at this table, I can see that, right, H1 has maximum probability value as 0.3, right? H1 has a maximum probability as 0.3. So, and it gives a result that, therefore, and for this hypothesis, right, we see that it is COVID negative, right? But if suppose I use the Bayes optimal classifier, I need to combine all the predictions. If I combine all the predictions of H2, H3, H4, how much do I get? 0.1 plus 0.2 plus 0.1. I'm getting 0.4. Right? And all these other hypotheses is stating that it is COVID positive. So now how do I apply the Bayes optimal classifier? So this is the formula for Bayes optimal classifier. Summation of probability that it is COVID negative, right? So COVID negative. So in this case it is 0.3 into 1 plus here and all it is 0. So you don't have to consider. So the probability that it is COVID negative, it is 0.3. Probability that summation of, you have to sum up for all the hypotheses. Probability that it is COVID positive for all the hypotheses, right, into probability that the hypothesis belongs to the class T. So how do you do it for positive? Here it is 0.1 into 1 plus 0.2 into 1 plus 0.1 into 1 plus 0.3 into 0. Anyway, it is 0 here. So I am getting that value as 0.4. So out of these two, this is more, right? Probability 0.4 is more than 0.3. Therefore, you can say that the maximum, this is the Bayes optimal classifier formula which I just discussed in the previous slide, right? This one, right? So you have to take the maximum value. So the maximum value I'm getting as maximum value that the class belongs to, which is which class, what is the maximum that it belongs to, COVID positive or COVID negative. So I just take, I'm getting the out of these two, 0.4 is more, and therefore the test data applying Bayes optimal classifier, I can diagnose that the patient is COVID positive. The new instance is COVID positive. Okay, so that's it about Bayes optimal classifier. This was the we had seen 4 different sessions on Bayes learning. Any doubt, please refer to all the 4 different lectures on Bayesian learning, where we went through NAIVE-based classifier in this state, and we also saw the different types of NAIVE-based classifier in this particular session. Any doubts, please let me know. So let's meet in the next session, where I will be starting with a new topic on artificial neural networks. Thank you so much.